Hey guys, welcome to this session by Intellipaat. So in this session, we're going to look into the Android application architecture. Before moving on with this session, please subscribe to our channel if you haven't already so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. Now let's take a quick glance at the agenda. So we'll start off by understanding what is Android application architecture. After that, we'll understand why application architecture is really important. After that, we'll do a quick comparison of architecture versus organization. Moving ahead, we'll be looking into the recommended mobile application architecture. Then we'll understand what exactly is Android Jetpack. And once that is done, finally we'll get into the Jetpack architecture, and that would be the end of this particular session. So now, without any further delays, let's begin with it.
So let's take a look at what is application architecture. Application architecture is a concept that lies at the heart of what we're trying to understand. So let us see what application architecture actually entails. Application architecture is a conceptual organization of different components of application which maximizes modularity, loose coupling, and testability. So these all seem like really huge words and difficult to understand. So let's try and parse them one by one. Before that, let us understand the problem that application architecture tries to solve. If you have ever built any kind of project, let it be Android, web, simple Python scripts, or any kind of project that requires a little bit of domain knowledge, which is to say that it not only is just something that you write in a single file, but it needs you to write multiple source code files, multiple classes, and then have them interact with each other. If you've ever written applications as that, then you may have come across a problem where you have to now swap out some internal piece of your application for a substitute. To give you an example, let's say that you have built an application which is having a MySQL database as the backend database that it uses. Now, let's say that tomorrow a new database comes along that proves to be a 10 times faster alternative to MySQL. It's more secure, it's easier to work with, and it removes many of the discrepancies that MySQL has. This theoretical database is going to be better for your application. But are you going to be able to substitute your current implementation's database interaction logic with this one? This is what the problem at the heart of application architecture is. When you have certain parts of your application so tightly integrated with your application that exchanging it for a newer part is going to cause a major overhaul of your application. And also, if you have not written any tests for your application, then any change you make in your application could end up breaking your application. The only way of finding whether or not it has actually broken your application or your application is still working intact is to start your application completely after the change. After you pass through all the errors and fix all of them, then you go through the entire application, executing every bit of functionality that's available and figuring out which of them work and which of them don't. And then you keep fixing and you keep reiterating over it. This is a painful process. Now, in order to solve problems like this, application architecture is something that really needs to be understood. Basically, application architecture means that when we're beginning to build our application, we try to firstly think about how we're going to, what are the pieces that we need to understand and how we're going to make them fit with each other. So for instance, how are we going to deal with persistence logic? Persistence means saving data in some place. It could be saved in a database, it could be saved in a cloud database, it could be saved in a local SQLite database. Depending on the kind of your application and depending on the platform that you're running it on, these choices are going to be made. Are these platforms going to be compatible? So if we have application on an Android application framework and an application on iOS, if both of them support iOS, can we swap or substitute code written for one to another if both of them support the same language or something along those lines? Modularity basically means that you can isolate logic that is related to one specific key task into one specific package. Let's say that you want to create a user interface. Now, to create a user interface, you don't need database, you don't need networking, you don't need threading. You only need to draw on the main thread. So are you going to be able to create a user interface that is going to integrate well with all the other applications? Similarly, are you going to create a database module which could be attached to your application and which could be removed and substituted for other kinds of databases as well? And finally, loose coupling. Loose coupling basically means that when you have code that can be substituted easily for other pieces of code, that means they are loosely coupled. In software engineering, the thing that we want to reduce is tight coupling. We reduce tight coupling by introducing loose coupling. Loose coupling basically means that when you are writing code, the code that you are about to write is changeable. If tomorrow some new database comes along and we can write code for that, then we should be able to remove the current database code and add that one which with minimal effort. And finally, testability. If you've ever written any kind of code, testability is really important. It may be the case that you have written only a few small projects, then you may not have worked with tests as much, but testing is an important application principle. This basically means that it gives you a feedback of whether your application is working or not. You write automated tests such as unit test, integration test, and acceptance test. And then whenever you make any change to your application, you can run these tests and immediately get a feedback on whether or not the change that you have made has broken any part of your code. If it ends up breaking any part of your code, you can go ahead and fix those bugs. And if it hasn't created any issues, that means that your change was successful and you can move along, unless you wish to refactor your code. So these are the kind of things that we need to keep in mind, and this is where application architecture is really helpful. Application architecture is a really broad topic. We're not going to be able to cover it entirely. We're only going to be covering it from the point of view of an Android application. However, we do recommend that you check out the different architectural concepts that are available. Now let's take a look at why application architecture is important. Application architecture is something that we use to figure out how we are going to organize our code or put our code in such a way that we're going to be able to get maximum modularity and testability and reusability. But why is it going to be important for us? What benefits does it provide? Application architecture is an important concept as it allows us to build applications that can have components which can respond to changes easily. Any application is something that is going to change eventually. Maybe the requirements for the application change, maybe the components, technology is going to change, maybe the libraries that you're using are going to be upgraded. Changes are just going to happen. So an important aspect of any application that we build is that it should react to changes well. If you have any kind of change that you need to implement in your application, does a majority of your code need to be shifted from where it actually is? If that is the case, then that means that your architecture is not good. Similarly, if any component needs to be swapped out, does the majority of your code needs to shift? Is there a fear that the code might break if you touch some part of your code? If that is the case, that means the architecture is not good. So application architecture allows us to enhance replacement and changeability and reduce the amount of problems that it can cause when we are doing something such that. Even when implementing new features, it could be possible that we might have to change some bits of code. And if the architecture is not good, then that change is going to lead to your application running into a lot of issues. So we have to take a look at that as well. Application architecture is really important, and many big companies such as Google, Facebook, Instagram, and many other kinds of applications that use Android, such as Spotify and all, they invest heavily in application architecture before writing a single line of code. The reason why is because if they don't, then as soon as they write the code and start churning out features, any kind of change which is going to happen is going to cause a lot of problem for them, and they won't be able to keep up with the competition. They have to understand that any kind of change that the application may face, it is possible that it will face, and we have to be able to respond to those correctly. Software is basically a product that should be very prone to change. Any change that happens, we should be able to respond to those changes effectively, and we should be able to write the code for that and integrate that code with the current application code easily. That's the entire process of writing application code, and this is why we write application architectural necessary code. This is why architecture is so important in any kind of application.
Just a quick info, guys. Test your knowledge of Android by answering this question. Which component holds data in a lifecycle aware way? A. View model. B. Data holder. C. Fragment. D. Activity. Comment your answer in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Alright guys, now let's take a look at architecture versus organization. Architecture and organization are two concepts that sound very similar, and they have similar concepts. However, they tackle very different problems. So let's take a look at how architecture and organization are different from each other. Architecture deals with how to make components interact with each other, while organization deals with how these files are organized or packaged. To give you a quick and simple example, when we're trying to build an Android application, we're creating classes. These classes depend on other classes as well to do their work. For instance, if you're trying to create an application in which you are getting information from a user, saving it to a local database, and sending that data to a web server, you need multiple classes to do simple jobs. One class to display the user interface, that would be your activity class, that contains your fragments and all. And by the way, if you don't understand activities, fragments, or any of these technologies, put down into the comment section below that you want us to make videos on that, and we'll make videos on that. Also, if you like the video, click on the like button and click on the subscribe button and click on the notification bell icon as well. Now, as we're discussing, that when you have an application in which you have multiple concerns, for instance, you can create the user interface using the applications. You can create user interface using application architectural principles and the basic principles of Android application development, such as activities, fragments, and many other kinds of things. Once you create that user interface, you need certain bits of code to save data to the database. Now, to save data to the database, you need a class for that, and you can write the class there and then import it into your UI code, and then have it execute the code that you need when a particular event happens. So when a user clicks on a button and you want to save all the information filled inside a form inside a database, you call that action. So you can see that what we're doing is we're actually creating a network of objects, each interacting with the other object, and we have to be able to understand how we're using it. So in cases like this, architecture is important. When multiple classes depend on each other and we want to make sure that even though they depend on each other, they are substitutable. I can, for instance, write a class that allows my application to interact with an SQLite database. I should also be able to write another class which makes it easy for the application to work with Firebase. Firebase is an online cloud service provider that allows us to store data and perform crash analytics and many other kinds of things. The service is available by Google and it's for free to use for a small number of services for a small quota for daily. You can take a look at the services as well. But if I want to save data to a Firebase Firestore, which is a database that is available in the Google Cloud platform, I should be able to write code for that and remove my SQLite database and replace it with my Firestore database code in a matter of seconds. This shouldn't take a lot of time. This is what architecture allows you to do. On the other hand, organization deals with how the code that we're writing is organized and packaged. And however that is important, it's not the most important part, and it shouldn't be confused with architecture. So in organization, we might create different packages for different kinds of databases. We might create different packages for user interface, for databases, for networking logic, for threading logic, and so on and so forth. So we have to be able to understand how we are going to write code how we're going to organize our code in order to understand the architecture and the organization. So let's take a look at certain architectural and organizational patterns. So there are several architectural patterns available for us to use. These are clean architecture, onion architecture, ports and adapters architecture, and there are many other architectures available as well. Clean architecture was created by Robert Cecil Martin, or also known as Uncle Bob. He has created this architecture in order to keep in mind how the application's domain should be at the center of the architecture. The application domain is basically the entities or the objects that you create that your application should use. If you're creating a e-commerce website, then students, admins, learners, teachers, these are all the entities or the domain, and the use cases, which are the features that your application provides. So features such as user logging in, student being assigned to a particular course, and so on and so forth. So these are the kind of things that clean architecture talks about. It is a wider concept. It isn't something that you can only apply to Android. You can also apply this to any kind of application you build, be it a desktop graphical user interface using Java, or be it a web service created using Python or Django. You can use these concepts all along. Clean architecture is a really important concept in the world of architecture as well. Then comes onion architecture. Onion architecture is almost exactly same to clean architecture, but clean architecture is a little more formal. It uses formalized methods of passing data from one layer of the application to another layer using requests. On the other hand, onion architecture is a bit more relaxed in that regard, so you can take a look at that as well. And then there's ports and adapters architecture. This was created by a software developer as well. Ports and adapters is also an architecture that takes similar approach to clean architecture. However, the way dependencies flow is a little different. So you can take a look at all of these kinds of architecture and understand which one suits your need the best. The main concept that these architectures are going to drive home are the concepts of modularity and dependencies. So let's talk about that for a bit so that you can understand what this means. Modularity basically means you should create boundaries around your code. Boundaries basically mean that if you have a UI related piece of code, then that should only depend when it depends on some other kind of application code such as database or networking. It should not depend on it in such a way that it locks itself with it.
Okay guys, quick info, if you're looking for an end-to-end Android development training, Intellipaat provides Android certification training, and those details are available in the description box below and you can check it out. Now let's continue with this session.
For instance, if you are creating a new instance of that database class in the same class, then that's going to be a problem. If you are importing that dependency via the constructor, then that's going to be easier. Now, dependency injection and the solid principles are really important in this case. So that's how the entire architecture system goes. It's about how you can organize your code, or not organize, but how you can structure your application in such a way that interaction between different components is kept either to a minimal, and whenever the interactions happen, we can make the interactions weak so that it can be substituted for other kinds of components that solve the same problem, such as a database that is an SQLite database to a Firestore database, and so on and so forth. Then comes the organizational patterns. Now again, organizational patterns are available, and these are often confused with architectural patterns. Many times what happens is when we ask people what kind of architecture does their application follow, the response is going to be either MVC, which is model view controller, MVP, which is model view presenter, or MVVM, which is model view model. And these aren't bad. These are not bad things. However, these are not architectures that as we speak about them. They're more about organization of code. So there are several organizational patterns available for us. Let's take a look at some of them. The first one is MVC. MVC is by far the most popular organizational pattern. It's called the model view controller pattern. It is especially popular in the web development community. If you have ever worked with any kind of web application framework such as Ruby on Rails, Laravel, or any other kind of application framework, you have come across model view controller because they make extensive use of that. Now, the way model view controller works, if I were to break it down, is it allows us to group our code into three parts: models, views, and controllers. Model is the part of our application that contains code related to database and logic related to data handling. So for instance, if you have some database related queries, if you have some object relational mapping, if you want to look at code that gets data from an external data source, imports it, converts it into the object, and passes it back to the caller, models are the place where you have to look for that. Different kinds of application frameworks use different kinds of models, and we can take a look at those as well. Then comes views. A view is basically the UI layer, the user interface, what the user sees. In the context of a web application, it is the either the HTML code or the JavaScript code that the user takes a look at. So when the user clicks on a particular button or particular component of a user interface, the application needs to perform certain tasks, and it needs to perform those tasks using a model. So that's why there needs to be some connection between the model and the view, and that connection is the controller. The controller is the piece of code that connects model and view. The model and the view should never talk to each other directly. So the way it happens is this: the user looks at the view, takes a look at a button, clicks on the like button. Let's say we are taking the example of Facebook, clicks on the like button. That request is sent to the controller. Controller takes a look at the information that is given to it by the request, figures out that the user with particular user ID wants to like a particular comment or a particular post. This is sent to a model, and model takes care of updating everything. And if everything goes according to plan without any errors, then a successful message is returned. If something happens that shouldn't have happened, let's say that the user did not have permissions to do something like that, the user was on the user's identification has been revoked, user is not logged in, anything of that sort, then an error is sent back. That's what MVC is all about. Now, it's important to note that this often gets conflated with architecture, mainly because model view controller is so popularized by the web, and many Android developers use this as well. In fact, many Android developers consider MVC as part of their architecture, which it isn't. Also, another thing to understand is that before Jetpack components, which we'll discuss in a moment, Android didn't give any guidelines on how you develop your application. You could have developed your application using any kind of architecture or no architecture depending on your choices. But since Jetpack components have come into play, they have created some specific kinds of architectures and have given us some guidelines on how you can write better code. And we'll take a look at that as well. But that's what Model View Controller is all about. Then we come to Model View Presenter. Here, model and view are the same thing. Presenter also does the same thing as the controller, but the presenters also got the job of getting the data from the model and then wrapping it into objects that the view can understand and then passing it along with that. So presenter's job is to get the data from the model, extract data from the data that it got from the model, and extract only the data that the user needs, and then send it back to the user. That's what Model View Presenter is all about. Finally, it's Model View Model, or also called MVVM. Now, Model View Model may seem like a really easy thing to understand at first. However, it deals with a concept called data binding. And we'll discuss data binding later on when we're discussing Jetpack components and architecture in a bit detail. But the simple idea behind MVVM and data binding is that when you have some data source that changes rapidly, let's say that you are creating a mobile application that is displaying you some data that is changing live. So for instance, stock market data about a particular cricket match or something like that. When the data changes on the server and the change is sent to the user needs to be able to react to that data, or the application needs to be able to react to that data and update it automatically. Now we can write code where we are checking the server constantly for new data, and as the new data comes along, we update our user interface. However, in Model View Model, and in data binding, all you have to do is just define in the view where you want particular value to be displayed, back it up with the data, and bind them together. So whenever this data inside your model changes, your view will update automatically and you don't have to do anything. This is also called the observer pattern, and Model View Model makes extensive use of that. If you've ever worked with C#, ASP.NET, or Windows Forms application, then this is something that you may be familiar with. So as you can see, organizational patterns and architecture patterns are quite different. They tackle different problems, they tackle different scenarios. So it's better to understand what the differences are and how you can use them than to blindly call MVC, MVP, MVVM, or any other kind of organizational pattern as your architectural pattern. So with that, now let's take a look at recommended Android application architecture.
Just a quick info, guys. Test your knowledge of Android by answering this question. Which component helps in local SQL data storage and object mapping? A. Live data. B. Automapper. C. Room. D. Dagger. Comment your answer in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
So the application architecture that we're going to discuss now is an application architecture that has been recommended by the Google Android developers team. This architecture is of course not a silver bullet. It's not going to be fit for all kinds of use cases. For most kind of application, this architecture either is completely good to use, or there may be some changes that you might have to do, but it's a good starting point. This architecture can be found also on the developers.android.com/docs. Documentation is available for Google's Android, and it's a vast collection of resources. It could be quite overwhelming to parse through the entire documentation because Android is such a vast library, such a vast framework, and such a big mobile platform. It can perform many tasks, so you can take a look at the documentation as well. But the entire application architecture that we're going to discuss now is something that is recommended by Android developers at Google. So it's something that you should really pay attention to and try and understand why each component is the way it is. So this is what the architecture looks like. We'll discuss each element of the architecture one by one. But if you take a look at the entire architecture, and this only deals with the mobile application part of it. There are other parts of the application such as the backend server through which interaction happens, authentication servers, many other kinds of things. But for a simple application, this is the architecture that we should follow. So how does the architecture work? What are the things? These are the different aspects of it. We have activity or fragment, which constitutes the user interface. We have a view model, have a repository. The repository is connected to both models and remote data sources. The model is backed by a local SQLite database, and a remote data source is backed by a web service or multiple web services, depending on the kind of the remote data source that we're dealing with. So what are these terms and why are they useful in an architectural construct? Let's take a look at them one by one and explain what they mean. First one is activity or fragment. If you have been doing Android application development for any bit of time, activity and fragment are really important concepts. An activity is a screen on your application. So whenever you open up an application, the first thing that you see on your screen, it's an activity. The entire screen, ranging from top to bottom, from right below the top notification bars to the bottom bars, is an activity. Now, activities are really expensive. Once you create an activity, you should try and retain it for as long as possible and not destroy it, because it takes time to create all the assets, combine all the resources, and draw the entire screen on the entire activity on the screen, because it takes a lot of time to parse through all the resources. Now, fragment is a part of the activity. It's a reusable piece of the entire user interface. So for instance, let's say that you have a tabbed user activity. For instance, if you have ever taken a look at the contacts application in any Android phone, it has a tabbed user interface. There are 3 tabs at the top: the recently dialed numbers, your favorite numbers, and your contacts. Now that's the kind of thing that activities and fragments allow us to do. Activity is the entire thing, and fragment is each of the smaller tabs that are available in your entire activity. Fragments allow us to basically make sure that we are able to go through the entire system. It's very easy for us to scroll through the entire activities using fragments. Fragments are easier and they are cheaper for us to create and destroy. So that's why fragments and activities are important. They sit at the top, mainly because the user interface is something that no other piece of your application should import. No other piece of your application, such as databases, web services, or any other kind of service, needs to import the user interface and make any use of it. They should be isolated and only talk to each other. So any kind of user interface code should be isolated at the top. Then we take a look at view model. View model, if you have been paying attention, sounds similar to the MVVM's view model pattern. MVVM stands for model view model. So it sounds quite similar, but there are notable differences. The view model that we're discussing here is basically a view model, or basically a data container that contains the data that your activity needs to access. The problem that we have by storing data inside the activity is that, let's say that you have an application, you have created an application, you have fetched the data that you want to fetch from a web service. Let's say that you created a Facebook clone. You have created all the information that you need to display on the screen using Facebook's web services, and you have displayed everything on the screen. Now the user decides to tilt the screen or change the orientation from portrait mode to landscape mode. And when changing the orientation, one thing you have to understand is that the activity doesn't just get rotated. What happens is that activity that was in the portrait mode, the screen on the portrait mode, is completely removed. Then the screen is rotated, and then the new activity is created and then drawn on the screen. So in cases like this, the data that was being held on by the old activity, although the activity has been destroyed, the data that was being held is still held in memory. And because of this issue, you can cause some memory leaks. Also, another issue that we have to understand is that view models also allow us to create lifecycle aware data sources. Android activities have their own lifecycle. Again, it could be a little tricky to understand what lifecycle means and how Android's entire ecosystem supports lifecycle. But lifecycle basically means when you have an activity or an application that is running and you put it inside in a background thread. So for instance, you switch application, you're scrolling through Facebook and you switch to a music player, switch through Chrome, then or you receive a message and you take a look at that and the application is pushed to the background. That means that the application is paused. That's the life cycle. So application starts, application pauses, application is resumed, application is terminated, and application is destroyed. There are many other phases as well. So this activity can be a little complicated to understand, but once you do understand, it has a life cycle. And view model allows us to extract the data that we want out of the activity. So at any point during the life cycle, this view model is completely separate, and when the time comes, this data can be destroyed separately. So activities don't depend on the view model, and even though activities may get destroyed, the view model can be persisted in memory if we want, and it can be removed as well. Then comes repository. Now a repository is a very generic concept. Repository basically means that it deals with data. It could be storing data, retrieving data, manipulating data, so on and so forth. Now, data storage and manipulation and retrieval is not only something that you do on your local mobile applications, local database. So, for instance, if you have a database, if you have a chat application and you send a chat message saying hi, then that message firstly needs to be stored on your local database so that even if the internet connection is lost, your mobile knows from where it needs to pick up sending data to the web services. After doing that, it needs to send the new message of hi to a remote data source or a web server that stores all the information about you, ranging from your username, the password so that you can be authenticated, your profile information such as your username and your date of birth, your address, image, URL, so on and so forth, with the messages that you have sent.
Okay guys, quick info, if you're looking for an end-to-end Android development training, Intellipaat provides Android certification training and those details are available in the description box below and you can check it out. Now let's continue with this session.
So your entire chat history will be stored on a remote data source as well. So if you uninstall your application and then reinstall the application on some other phone, log into your account, that data can be downloaded, which was stored on the remote data source and can be used to display to you what the chat history has been. So that's what the term repository is about. It's about abstracting away what the word repository means. The term repository here basically represents some data storage mechanism. Now this has been connected to both a model and a remote data source. Let's take a look at those. The use of a model is quite deliberate. A model is basically a Java representation in case you're using Java. If you're using Kotlin, then you can understand it as being a Kotlin representation of the data that we have. So if you have some data that you need to store inside an SQLite database, you can't just directly run queries. You first need to create a class. The class contains all the data that you need to store. And then you map that class to database tables, run queries on that class, the data contained in the object of that class, and so on and so forth. So that's what a model is. It is used to represent a table inside a database or often referred to as an entity. So that's what a model allows us to do. Model is backed by an SQLite database. SQLite database has become one of the most popular databases mainly because it is used inside Android. Android makes use of SQLite database. It's a very lightweight database that is file based and not server based. So there's no web server running in your memory and nothing of that sort that needs a lot of memory intensive resources. So that's what a model is about. And a repository is connected to the model so that it can store data remotely or locally. So in case you are trying to send some message, but the internet connection is not good, you're traveling inside in a train or a car and you are traveling between network providers. When you send a message saying hi, it's first stored on your local database using a model. Then that database stores all the information that it needs to store, and then we move on to a remote data source. So that even if the remote database or remote data source fails and the request is not sent, or the request is sent but for some reason the response wasn't received, we still have a local database that keeps track of whether or not this data is synced with the remote database. Now the remote data source is contacted using networking. What we do is we send some data to the remote data source, and that data is sent via networking code. That also is something that we need to worry about. So we'll take care of that when we're discussing the architectural components. But what happens is using networking, we send the data and the web service takes a look at the data, takes a look at the authentication information, whether or not you are logged into the application. If you are logged in, then the application sends some token with the request. The token is verified on the server. If the token verification is successful, then it gets some data. That data is then used, and using that data, we store it inside the remote data source. This could be a backend web service that is backed by a PostgreSQL or MySQL database server. It could also be a file-based system. It doesn't really matter. We just need some place to store the data that isn't on our system, so that even though our application crashes, our mobile system crashes, or some network issue happen and our mobile system freezes, or some issue happens and we need to switch devices or sync the data, we can do it using the remote data source. So as you can see that this architecture promotes resilience in our applications. Resilience basically because even though our application is working in the similar context of an Android application, we are taking immense care of firstly separating different kinds of responsibilities, such as the UI responsibility is separated to activity. View model's only job is to get the data from the repository and then show it to the activities. It's not supposed to import activities. It's not supposed to instantiate an activity. Repository's only job is to get data and save data to remote and local data sources. Now, again, it's not a silver bullet. You need to figure out which pattern works for you the best. If you think activities are great for you to use, you can use activities. If you think view models are better for you to use, you can use view models and not use repositories. If you think repositories are good for you, but models and the remote data sources both do not make sense, you are only going to use remote data sources, you can do so. However, do note that when you remove one component from this architecture, you are letting go of certain benefits. So for instance, if you remove view model, that means you're storing data inside activity and you risk memory leaks. If you remove repository, that means that you are polluting your activity or UI related code with the responsibility of getting, storing and syncing the data with both remote and local data sources. If you remove the local data source, then you get into the problem of network latency. If you send some request but the response doesn't come, then your application is going to forget the request was sent. If you let go of the remote data sources or web services, then what you have is just a local data source backing your claims. And when your application's data is deleted, or you log out of your application, or even when you uninstall the application and reinstall it on your own system or some other system, that data may get lost and you have to start completely from scratch. You have no memory of whether or not your application has no memory of whether or not you have sent any message previously. So with that, now let's take a look at other architectural concepts. Now let's take a look at some architectural concerns. Architectural concerns are basically going to be about the kinds of things we have to worry about when we're rolling out our own architecture. For instance, the architecture that we have seen thus far that was recommended by Google developers is just one kind of architecture. Maybe you don't find it that appealing for your application and you want to build your own. In fact, the architecture that we just saw is an architecture that was recommended by Google recently. Before this, in Android application, no recommended architecture was there, so people rolled out their own architectures. Depending on how you wish to architecture your application, there are certain aspects of an application that you need to keep in mind when you're trying to create an architecture. What are these applications, especially in Android applications? So what are these applications? How are they going to affect our Android applications architecture, and how should we take care of them? And let's take a look at these concerns or components. When building an Android application, there are several aspects of the application that needs to be thought about when making architectural decisions. These are the 6 of the most important concepts. Now, again, these are not the only 6 things that you need to worry about. There can be other things as well. However, these are the most fundamental concepts that you need to take care of when you're designing an architecture. Different components of your architecture can deal with different things that we are discussing here. For instance, one component can take care of the user interface, other could take care of the life cycle, and that could be a one-on-one mapping on this topic. Or it could be that multiple take care of one topic, but the responsibilities that the one topic entails have broken into 2. So that could be it. The topics that here we have mentioned are the user interface, life cycle, data processing, data storage, networking, and threading. Let's take a look at them one by one and take a look at possible solutions that we have in Android. First one is user interface. In case you don't understand user interface basically allows us to see what's on the screen and allows us to interact with our application. Now, in Android application, if you have been doing Android application development for any number of time, the main way user interface is built is through XML code and JPG and PNG and image assets, font assets, and Java or Kotlin code. Now, the thing to understand here is that the entire Android application user interface can be a little difficult to create. Not to say that the application's infrastructure or the tools that are provided are bad. It's just that there are so many technologies and so many different ways of creating the user interface that we need to be able to understand how to work with it. Also, user interface needs to be isolated. Isolation is a grave concern in user interface, mainly because if you're trying to build an application that is not isolated, then that means that the problem that the application is going to face is going to be that of high coupling. If your user interface code is depending on database, networking, and other kinds of operations that really shouldn't be its concern, then there is a problem that you need to face. So try to understand these concepts and try to push code relating anything other than user interface out of the user interface packages and code as much as possible. So creating a user interface in Android application, you can make use of activities and fragments. Nowadays, fragments have gotten a much better support in the Android ecosystem. You can take a look at the entire fragment support library as well as understand how fragments integrate with Android. Thing to notice is that fragments, there are different kinds of fragments, how fragments interact. So make sure that you're working with the latest version of the documentation. If you're taking a look at some article written on some website that's not developers.google.com or developers.android.com, then it's possible that that article is older and references technologies that are not the latest ones, which means either their support has been dropped or they have been deprecated. Make sure that you understand that. Then comes lifecycle. In the previous architecture, the user interface and the view model were broken apart from each other, mainly because the UI, the user interface that we were discussing, was isolated to the top layer, which was activity and fragments. The view model took care of the data and managing the lifecycle of the application and keeping the data separate from the lifecycle. So we need to be able to grasp the lifecycle aspects of the user interface and the entire application. In Android, since it's an entire operating system, it allows you to run your applications in the background as well. So when you are running an application and you suddenly click on the home button, go to your application drawer or your operating system's home screen, you turn off your device or basically turn off the screen of your device, the application is still running in the background. If it's doing the thing that it shouldn't be doing, then your battery is going to drain really fast. Let's say that you are building an application that is downloading some image that is a huge image, let's say 100 megabytes of image. And while you're downloading that image, you are also processing that image and compressing it. Maybe you're converting it from one platform to another or one format to another. This takes a lot of time and this takes a lot of memory. If the lifecycle aware understanding is not there, then it could be possible that when the user basically switches from your application to other application, the entire operating system starts behaving really slowly. Or it could be the case because it's supporting the application that you have written, the background processes are not stopped and still running, still draining the battery, still draining the processing power, and another application is being running on top of it. Also, if you click on the home button and just close the screen, even though the application might be in a paused state, if you have scheduled the work to be completed in the background without the user's permission, then that is going to drain the user's memory and battery quite a bit. So you have to be aware of these context and understand how and when to use lifecycle or application lifecycle to make correct decisions. Then comes data processing. As we discussed in the lifecycle aspect of the application, there are certain tasks that need to be performed in the background because they can take a lot of time and they can cause a lot of memory usage. Data processing is an important aspect of any Android application. Any application that we do use makes heavy use of data processing. Things such as drawing bitmap images on the screen, drawing vector images, allowing users to reshape and resize the images, playing games, OpenGL graphics. There can be a lot of different kinds of data that you need to parse through. This is just a small subset that I'm describing. This kind of data is going to be incredibly difficult for an Android system to grasp or to parse through, mainly because Android, you have to understand, is a completely different ball game than desktop applications, because we are trying to create applications that run on mobile platforms. These platforms are having lower power than your contemporary computers or laptops. They have lower speed, less resources to use, and limited battery life. So we have to be very strategic in how we direct these limited resources into making stuff happen. Data processing is an important aspect also because it takes up a lot of time or it takes up a lot of resources that we have discussed, and if not managed properly then it could take a lot of problems as well. This processing needs to be taken care of by multiple ways. You can take a look at those ways on the Android's development documentation, how you can create multiple execution queues, how you can schedule the task, and so on and so forth. So as we're discussing data processing, there's different kinds of data that we can process, and because of the limited resources, we need to be very strategic of how we can use it. So when we're creating our applications architecture, we have a specific portion that may or may not deal with data processing. At that point, we have to be very concerned about how we are going to use the limited resources available to us. Now comes data storage. As we have already taken a look at in the previously recommended architecture by Android developers, data storage is a it could be a point of failure for an application if not dealt with correctly. Mainly because storage of data is really important in any application, but it could be handled in multiple ways, or you can handle it in just one way as well. For instance, in the previous recommended architecture slides, we took a look at remote data sources as well as local data sources. Both of them store the data. To store the data is to make a copy of the data in both local, which means your own mobile phone, and on a network. This is done to maintain resilience for your application. So in case if the network goes down, you still have a local copy to work with. And networks could be creating the data storage network or using a cloud computing network. That's entirely a different understanding of it. But since we're talking about Android applications, we just need to send the data to the respected services through over the internet, and they'll take care of storing it, persisting it, making sure that there are multiple copies of it spread throughout its network, so that even if one server goes down, other servers can pick it up and send it back to you.
Okay guys, quick info, if you're looking for an end-to-end Android development training, Intellipaat provides Android certification training, and those details are available in the description box below and you can check it out. Now let's continue with this session.
On the other hand, in the local system, when we are using data storage, we need to be able to understand how we are going to store it. There are not a lot of options because we only use SQLite, but there can be different table schemas that we can come up with that could lead to multiple joins, that could lead to multiple aspects, or you could also store it inside a file system data. Like you can store it inside a CSV file, you can store it inside a text file, a DAT file, whatever you want to do. But it's important to understand that all of these concepts that we have discussed thus far are important, not just from the point of view of storing data, but also from the point of view of resilience. As we discussed, architecture needs to make your code modular and more usable, testable, but it also needs to ensure resilience in your application. So even if one part of your application goes down, let's say that you are suddenly not given access to your disks, or your application is not given access to access the internet, or maybe the server is down, or any other question, the data that is stored thus far can still be used from the local data sources. So make sure that you understand the entire breadth of the problem and how you can tackle the problem as and when it comes along. Then comes networking. Networking is another really important aspect of Android applications. We don't only just use networking for storing and retrieving data. We also use networking for sending messages, sending points to the server, analytics data, any kind of thing that we need for the application to be understood. For instance, if the application or certain part of an application stops working, we need to send the analytical data back to our server so that they can digest it, and then we can take a look at what are the major causes that are causing certain applications to fail on certain devices. This is also how Google's entire bug tracking feature works. Also, if certain services stop working or if you run into some issues, this also happens. And also, of course, when you are using an application and they want you to give an internal rating to their platform, such as they give you 5 fields and allow you to rate them from 1 to 5, that's totally a kind of data that they're collecting from you in order to increase their productivity and understand how the users are liking their product. All of this data needs to be shared via a network, and networking can be a complicated task. mainly because the kind of data that we're sharing could be of multiple types. There could be multiple restrictions on the multiple types of data, and we need to take care of all of that. If I have some data that is in the text format, I need to convert it into JSON, send it back to the user. If I have some data in a file format, I need to create a multi-part response, a request and response cycle, and then send it back to the server. That server needs to be able to access the multi-part data. If I have some authentication information, such as a JSON web token or any kind of token that can authenticate me, I need to use that as well. And other kinds of networking tasks, such as getting the OTP, sending the received OTP, confirming the OTP that was received was correct, and so on and so forth.
Just a quick info, guys. Test your knowledge of Android by answering this question. Which component holds data in a lifecycle aware way? A. View model. B. Data holder. C. Fragment. D. Activity. Comment your answer in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
So all of these aspects need to be taken care of, need to be understood, and they need to be understood in the context of the device that we are going to be deploying our application on. If you're deploying your application on a device that is going to be low powered, then we need to consume as less of a memory and resources as possible. And networking can play a big role in that. Finally, we come to threading. Threading is an important aspect of any application, mainly because it allows us to provide a really good user experience. For those of you who are not aware what threading is all about, let me just give you a quick introduction. Let us say that you want to make a request to the web server to get some data. This takes a lot of time. When you open a request to a web server, the web server may take at least 1 second to respond with all the data that is available. This response includes opening the connection, sending the request, the web server parsing the request, getting data from another web service or a database, converting that result into JSON or any format that is available for you, sending it back to you, and then you receiving all the data. This takes at least a second. So this could mean, or it could take even more than a second, let's say 2 seconds or 3 seconds, depending on the kind of information that you're requesting. If the request that you have sent and the response that you have received, if there's a lot of time taken between these two things, that means that the user is going to see a frozen application for that time period. Let's say it takes 3 seconds and the user is trying to, after clicking on the image, it's trying to scroll through the entire page, but it's not able to. The application stops responding. Or maybe the user clicks on the like button and all the network needs to do is send a request that tells the entire backend system that the user has liked a photo. Now the user may click the like button, then try to scroll down, but the problem is when it's trying to scroll down, the application is not letting it because the application is still waiting for the response from the server. Since everything is running in the same thread, everything is running on the same process, that means that we are blocking the user interface thread. In Android, however, this may not be possible because tasks such as these networking tasks and any other long-running tasks are not allowed to run on the UI thread or the main thread, so that the user experience can be kept safe. In earlier platforms, it was allowed, but I think from Android 4 or 4.1, this was disallowed. From then and onwards, whenever you tried to send a network request from the main thread, the application would crash with the UI networking on UI thread exception. So this is what threading is all about. You need to decide the kind of work that you're going to do, how long that work is going to take place, and if it's going to take a longer time, then what are the best strategies. In Android, however, there are many kinds of ways that you can deal with it. In Java, for instance, you can use executor services, you can use thread pool, you can use simple threads, you can use async, you can use async task class created in Java, although that's a little older class but can still be useful. In Kotlin, however, there are different kinds of ways you can deal with it. You can use the concept that we have discussed thus far, but Kotlin also has a native feature called coroutines, which allows you to write asynchronous code in a synchronous fashion. So you can take a look at that. Now, how you're going to write that code, how you're going to integrate it in your entire system. Does that system work in a way that you want it to work, and is it going to be replaceable? For instance, tomorrow today you're using a thread pool, tomorrow you want to use async task. Is it isolated behind some interfaces? Is it easy for them to access, so on and so forth? So we have to be able to understand all of this. And these are some of the concerns that you need to take care of. These are some of the major concerns. There are many other concerns as well. Now, as we have discussed thus far, Android has no default way of tackling these concerns. If you ever come across any of these issues, by default, Android had no ways. It had multiple ways of solving this, but no recommended codified way of using one over the other technologies. It was all left on the users. After this, Android developers came along with good architectural components and defined some recommended patterns. We have taken a look at the recommended architecture. We have taken a look at the concerns that the architecture, a good architecture, should try to address in an Android application. Now our job is to take a look at the different Jetpack components and how we can use them. So let's take a look at that. So Android Jetpack is a set of libraries and components that make it easier for us to write Android applications. The Jetpack components were created by Google. It's an official Google package. It's for Android application development. It was created because the earlier versions of Android developing applications, in that there were a lot of problems, and these Jetpack components come to solve these issues. The issues that were created because of the older way of doing things, some of the issues that we have already taken a look at. These issues were that it was difficult to figure out how to merge the UI and the data layer, how to find out where to put what kind of data, and so on and so forth. This kind of information can be a little difficult to parse through. So Jetpack components allow us to write the code in a more concise and simple manner. Also in Android, because of the various versions of Androids that were released, there were several best practices out there. That made it really difficult for someone who was trying to get started with Android to understand which one should they use with the current version of Android, and if they wanted to support a later version, which one to use. Many of the articles that were written for the best practices in, let's say, 2015 were completely obsolete and were now considered bad practices in 2018 because of the way that newer versions were released and newer ways of doing things came along. The older ways were soon either deprecated or removed entirely from the operating system framework. So keeping that in mind, Android came up with Jetpack. These components are created and maintained by Google. They address a lot of the common issues that people face when they're developing Android applications, and they make developing Android applications really easy. So how does it fit with the entire architecture problem that we are trying to solve? Well, among these sets of libraries, these libraries are actually divided into 4 sections. One of the sections is called architecture components. These components are written so that we can write loosely coupled code and handling different aspects of an application architecture easier and more approachable. Think about it this way. Since we have discussed the concerns that an architecture needs to address in an Android application, one of the concerns were threading. Now, by default, threading is a very, very difficult task in Android, mainly because of the sheer number of ways through which you can do threading. Now, if you're using Kotlin, then you can easily use a coroutine. However, using coroutines is not as simple as it might sound at the beginning. But in Java, for example, there are many ways of doing things. Firstly, you can create your own thread, which is doable, but then you have to then manage the runtime of the thread and when to execute and how to hook into the different life cycles of the entire thread, as when it starts, when it pauses, when it resumes, so on and so forth. Again, there's the async task utility that Android provides that you can use in order to create a task that will be governed and monitored and executed by Android. Also, there are other ways of doing it, such as creating worker pools, creating thread pools, creating executor services, using runnables. There's like a million ways of doing things, and you can mix and match them. But in Jetpack, there's Work Manager, which we'll discuss in a moment, and that allows us to figure out how we can schedule a task that either is long running or is recurring. So, for instance, if you have some task, let's say a backup task, which you need to perform every day at 2 a.m. in the morning, if the internet is available, and if the internet is not available, then executed once the internet gets available. Now that is performed using Work Manager. You can do it now using Work Manager. These libraries are stable, so you can take a look at them and use them in your production build of the application as well. There are many other kinds of Jetpack libraries available as well. The architecture components, there are several. We'll be discussing 8 of the most important ones. So let's do that now. So let's take a look at the Jetpack architecture components. Jetpack has several architectural components. Some of the most important ones are Room, Work Manager, View Binding, View Model, Live Data, Navigation, Paging, and Data Binding. Let's discuss them one by one and let's see what these actually allow us to do. So the first one is Room. Room is an ORM. ORM stands for Object Relational Mapper. As we know that for our local data sources, it is typically backed by an SQLite database. Now, SQLite is, although quite familiar for people who have worked with SQL, it's not so easy to work with when you're using Java. So if you're using Java, then you have to download the library, configure the SQLite library, create classes called plain old Java objects or POJOs, which only contain the fields that we want to use and their getters and setters. So for instance, if I want to create a user table in which I have the user ID, username, user password, and the date of birth, all of that needs to be translated into Java using a plain old Java object class or POJO class. The class contains the ID, which could be a string or an integer depending on the kind of ID that I have chosen, the name, password, which are both going to be strings, and the date of birth, which is going to be date or date time, whichever one you want to use. So using this, we can then get the data from the table that is stored inside SQLite. After getting a row of that data, we need to map information from that row of data into our plain old Java object class, which is the user class. This class is also called an entity class because it represents a row inside a table named user. So that's how Room works. Room allows you to not write the tedious bits of code that you have to write in order to make things work. So you have to firstly know the SQLite queries. You have to then know how to map these values from the table to the entire system. If you have joins in your entire system, then that becomes incredibly difficult. So Room allows you to not do that. It does it for you. So it takes care of the data layer.
Just a quick info, guys. Test your knowledge of Android by answering this question. Which component helps in local SQL data storage and object mapping? A. Live data. B. Automapper. C. Room. D. Dagger. Comment your answer in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
If ever you're building an application that is backed by an SQLite database, but if you're testing it or writing a unit test, then you have to create a database that is in memory. Room does that automatically for you. When you're testing it, just configure it to use an in-memory backed local data source and it will work. So that's what Room allows you to do. Now, Room is a library that was available in earlier versions of Android as well. However, this has been completely revamped and is now brought into the Android Jetpack components. Also, Android Jetpack components come under the Android X packages. So when you're importing it, you have to write Android X dot and then the entire package name. Then comes Work Manager. As we have already discussed, Work Manager is not that difficult to understand. Its only job is to schedule tasks that are long running or recurring. Suppose you want to parse an entire image and convert it into black and white, but you want to do it in the background. Now, to do it in the background using threads, it's going to be really difficult, but Work Manager simplifies this process greatly. All you would have to do is use Work Manager, schedule a task either in the background currently, or you can schedule it for later on. So for instance, the user specifies that they want the task to be scheduled for 2 a.m. in the morning when their mobile would be on charging, and this would work just fine. So you can do so as well. This kind of scheduling also takes care of if the application crashes that you had scheduled, or if the internet connectivity is not there. You can specify several rules that you could only perform this task if the disk has enough space, if the internet connectivity is there, and you can create an entire pipeline of work that Work Manager will take care of. So Work Manager is a way of creating very resilient processes that will take care of what you are writing and how you are trying to process a particular request. Work Manager is also a library that is available in architecture components. It greatly simplifies how we can schedule a task, and it takes care of a lot of the tedious tasks of making sure that if the application restarts, that the task resumes from where it had started, so on and so forth. Of course, there's a lot of configuration needed to get that done, but for normal day-to-day tasks, Work Manager is a great library. Then comes view binding. View binding is an entirely different kind of architecture component. If you have ever worked with Android before, you know that when you are trying to create a user interface, you first have to write XML code that specifies how your user interface should look like. Then in your Java code, you have to inflate that XML view. Inflation basically means creating a Java object out of the XML class and or out of the XML file. So when you create that, you have to then go through the entire tree of the view and find a particular view using an ID that you have assigned it. So for instance, if I have an activity in which there is a text box where the user is supposed to enter their name, and I want to have an access to it in my Java code. To do so, I would have to use the find view by ID method and pass in the ID that I had assigned to my XML file. Now, that's not very difficult. However, it could be a little problematic if your view is complicated. So if there are multiple nested views inside it, then your process of finding the view with the particular ID is going to be really slow. To overcome this issue, view binding was introduced. View binding basically creates a compile time dependency of your entire XML view tree. So what happens is you can write the ID, and when your program is compiled, it will generate a view binding class. And now you can access the views using that class. This makes the lookup really, really fast. So instead of you having to then jump to the XML, go through the entire list of the tags that were available, list of the entire components that you are displaying on the screen, and then find the ID that you want to find and then apply it to your system, you can simply use it here. So view binding greatly simplifies that. It is used to speed up the view finding process, and there are many other kinds of things the view binding does automatically for us. Now let's take a look at view model. Now view model, as we have already discussed, is just a data container that takes care of containing data that our user interface components might need. Now view model has been created into a library. This library contains a lot of different libraries that are available in Jetpack as well, and this library can be mixed and matched with the other components available as well. View model's job or sole job is to contain the data and be aware of the life cycle. Life cycle, as we have already discussed, if the application is switched from landscape mode to portrait mode or portrait mode to landscape mode, if the application is switched into the background, if it's brought into the foreground, if it's paused, if it's removed from the background running applications, anything could happen at any time, and view model takes care of all of that. Once you have inherited from the view model class, then you can just fill in your data, and Android will take care of cleaning up the view model instances in your memory automatically as the activity is removed. Then comes live data. Live data is another library that is created by Android for Google for Android application development. It is an observable data container. If you have ever worked with any kind of refactoring tools and read much about the available patterns that you can use, observable pattern basically means that you have two classes, one called the observable and the other called observer. The observable classes basically provide certain ways for other applications to monitor it. So for instance, if I have a class which has data that will be changing every now and then, and I want to notify all the other components of my application that data in this application has changed, if you want to reload. The observers allow us to do that. Now in live data, we can use it with view models, and we can back it up with our live data module. So if we have view models and we back it up with live data, that means we have observable data binding. And now if I have, for instance, a text box in which there's some text, and that text is being stored in memory, which then in turn is being displayed somewhere else on the screen. Now, as soon as I change the value in the text box, that value that was being displayed on the screen will change automatically. I don't have to run through the entire code and figure out if something has changed or not. That's the benefit of live data. Live data greatly simplifies working with applications that have data sources that change, that have values that are changing a lot. If it's an application that takes care of some live data, such as some sports scores or some stock markets, then live data can help you do that as well. Then comes navigation components. Now, if you have worked with Android applications before, you know that to go from one screen to another screen, that is to remove one activity from your screen and create another activity and navigate to it, can be easier than you could think. But if you have a typical architectural model and you have multiple screens that you want your users to be able to navigate to, the entire process can become difficult, and it can be really difficult to visualize it entirely as well. Keeping that in mind, they've come up with a navigation component as well. The navigation component allows us to define screens that the user can navigate to, and we can visually drag and drop screens and visualize how the user can go from one screen to another. What button press can allow us to do so, and so on and so forth. One issue that comes with navigation components that earlier used to happen was that we had to manually manage the history of the navigation. So for instance, if the user goes to some other tab, then comes back, then it goes on some activity, then comes back, then goes on to some fragment, then presses the back button. How does the activity manage the back button response? All of that can be a little difficult to grasp on your own, but navigation components make it super easy, so you can use that. Then comes the paging library. Now the paging library's job is to get the data that you have gotten from a data source. Let's say that there are 100 rows in that, and chunk it into smaller pieces or smaller pages. So for instance, let's say that I have requested some data from a web server. It gives me 100 rows, or let's say 500 rows of data. Now mobile applications are not that good at displaying 500 rows of data all at once. What you can do is display 10 rows and create a button that tells the users to access more data. Now if you had done it the older way would have requested more data time by time. So for instance, it would request 10 rows at first, then request 10 more rows, then request 10 more rows. As you can see that this takes a lot of time. This also means more network request, more load on your server, depending on how many applications are accessing the data and how frequently the access happens. So in order to overcome all of this, paging allows us to fetch a large volume of data and then store it in memory, and then page it as the user asks for the data. In the meanwhile, you can also implement some caching and some background fetching information as well, so that if the data changes, then you can fetch new version of the data. However, usually that does not happen that much. Finally is the data binding. Data binding is a library that makes it really easy for you to bind data to your existing Android architecture components. So for instance, if you have a UI component, let's say you have a button, and the value that is being displayed inside that button needs to change depending on some data that you have already gotten from some other source. Let's say a database, let's say a web service, could be anything, could be from a previous activity as well. So to do that, you can use data binding. Before data binding, the way it would happen is that you get the data, you find the data from the database, you update the view, and then you have to set up some way to make sure that the view stays updated. So if the data changes, then the view needs to know about the change in the data, and then we need to update it as well. Data binding, on the other hand, takes care of this problem for you. So all you have to do is define what is the data source for this view, and Android will do the heavy lifting for you. Data binding greatly simplifies building UI components that are backed by data sources. So you don't have to worry about going through all the data sources, figuring out how we are going to display it, and then displaying it one by one, and then making sure the data and the UI stay in sync. So these are all the libraries that are available for us to use. Of course, there are many others available as well. Jetpack components are great, and they are releasing new features and new components every now and then. There are components for testing, figuring out how to create the UI. Jetpack Compose is a new component that currently is in alpha version, I believe, and it is used to create user interface with a bit more declarative nature. So you can take a look at all of that. So these are the libraries that we wanted to leave you with. Hopefully this has whetted your appetite. And with that, we've come to the end.
Okay guys, quick info, if you're looking for an end-to-end Android development training, Intellipaat provides Android certification training, and those details are available in the description box below and you can check it out. Okay guys, that's it for this session. I hope this session was helpful and informative for you. If you have any queries, leave a comment down below. Or if you have any new suggestions for us to make as a video, please leave that also in the comment section down below. So thank you, meet you in another session.